Good afternoon. My name is Professor Tiffany Lipkin, and this is Collaborate Session 1, Week 1 for Psychological Research Methods, okay? And today we're going to talk about, I'm going to go over some course and the content, different things, and then I have a video video presentation I've created, like a PowerPoint thing. It's some new technology thing I'm trying, so we'll see how it goes. But otherwise, and it's basically, we're going to talk about the stuff for chapter 1, pretty much chapter 1 and 2, okay, in your textbook, which is like hypothesis, understanding knowledge, using a hypothesis for research or a problem, that kind of topic type thing. So it'll explain it. I'll explain it a little bit more. All right. So here's our course. Okay. As you can see, you have discussions here, okay, and it gives the date. There's a total of 5 discussions, and as you can see, they're kind of broken up, okay. Announcements are here, okay. All right, and then if you need to message me, here you go, okay. And I usually see them. I'll usually get back to you, okay. So other things are, here's student resources, okay. Pretty much all those different things you need. Here's your stuff for if you're having problems with Cengage and MindTap, like there's technical support and different things, you can find it there. Here is the weekly sessions, so that we're going over now, for example, and they pop up like that. Okay, and then here is your PowerPoints, and then APA resources. So if there's APA stuff, it's pretty much here that you'll need, okay. This website here for the APA is really useful. Okay, as you can see, it covers everything, and it has tons of stuff. APA or APA style, and you can there's these instructional aids. So if let's say you're not real great at APA and you're maybe getting ready to go to grad school, or you're going to do an assignment, or you're needing to supplement your stuff, there's these instructional aids on almost everything, okay. So you can find all sorts of stuff. You can even look at the publications as well, okay? So it's useful. Okay, and that's APA. I also have a textbook here that is the 7th edition that pops up in Cengage. That if you need more, like, I want to access my questions, it's right here, okay. So just something it's something that's there. Okay, and then I have highlights, and if you're trying to find a credible source, which is important for people because sources, you need to use sources for your research. Okay, then this is where you need to use to get access to the other courses. So okay, so here is the course syllabus. If you want to learn stuff about me, if you want to learn my office hours, the database, the link, here's the writing lab and tutoring, ethical use, and if you need to file an incomplete, for example, you get the flu or something, it's something to know where it's at. So this is the assignment you have to complete to unlock these. And then here's a way to introduce yourself and just, like people go, and just like if you have if you want to find a classmate or something, but that's kind of your area, like break the ice. And then when you get to week 1, here's the thing that tells you everything you need to know, okay? So for example, there's a lot of stuff that you got to do, as you can see. Anything here in bold is due, but you can see there's time. Oh, okay. Oh, all right. Well, I thought I changed the dates. I guess I didn't. Okay, so I'll have to update those dates while we're doing stuff. I thought I had updated them. Okay, I'll update the dates. And then like here's your discussion post. And the MindTap stuff, and then there's some quizzes, and then I like to include AI in this course with some learning about how AI applies, different things like that. So just some, if you're interested in something, and ethical use, because it's kind of what we talk about, especially like when you're looking at the scientific method, the research process, and different things, because people are using AI to help supplement a ton of stuff. But this is the content we're going to talk about here in the video that I have. Okay, so let me pull up this video here. And we'll do that, and then I'll come back with some stuff.
Good afternoon, everyone, and welcome. Today, we're diving into the fascinating world of the scientific method and how it applies specifically to research in behavioral sciences. We'll explore everything from formulating a solid hypothesis to conducting advanced data analysis, and even touch on the important ethical considerations that guide our work. I'm excited to take you through this journey step by step. Let's get started. The scientific method is essentially a structured way to gain knowledge by posing specific questions and then seeking careful, well-founded answers. It's not just about one way of knowing. Instead, it brings together various approaches like tenacity, intuition, authority, rationalism, and empiricism. Each of these methods has its strengths and weaknesses, but by integrating them, the scientific method overcomes their individual limitations. This combination helps ensure that the answers we find are not only accurate and reliable, but also based on empirical evidence. Additionally, these answers are objective and can be verified by others, making the knowledge publicly accessible and trustworthy. This systematic approach serves as the backbone for exploring and understanding phenomena, especially in behavioral sciences, but its reach goes far beyond that. Ultimately, the core of the scientific method lies in producing answers that are solid, evidence-based, and open to scrutiny. The scientific method is a structured approach that helps us understand the world around us through 5 key steps. First, we start with observation. This means noticing and identifying a behavior or phenomenon that sparks our curiosity. Next, we move to hypothesis formation, where we create a tentative explanation that can guide our investigation. Once we have a hypothesis, we make specific predictions that can be tested. The fourth step is systematic observation, which involves carefully planning and conducting experiments or observations to test those predictions. Finally, we reach the conclusion, where we analyze the data we've collected to determine whether it supports our hypothesis, needs refinement, or should be rejected altogether. Each step builds on the last, ensuring that our understanding is based on solid evidence. Every research project begins with a question or an idea about how different variables might be related. This initial curiosity is what sparks the whole process. From there, we develop a hypothesis, which is essentially a tentative and testable answer to that question. For instance, if our research question is whether using visual images affects memory, our hypothesis might be that using visual images leads to better memory performance. This gives us a clear direction to focus on. This hypothesis is crucial because it shapes the entire study, guides how we design our experiments, the kind of data we collect, and how we analyze and interpret the results to see if our prediction holds true or not. So, the hypothesis acts as a roadmap for the research journey. When we talk about a good hypothesis, there are 4 key characteristics to keep in mind. First, it needs to be logical. This means it should be based on existing theories or previous research findings, so it's grounded in what we already know. Second, it must be testable. That means the variables involved can actually be observed and measured in some way, making it possible to gather evidence. Third, a good hypothesis is refutable. In other words, it can be proven wrong if the data doesn't support it, which is crucial for the scientific process. Lastly, it should be positive, clearly stating an affirmative relationship or effect rather than something vague or negative. These elements together help ensure that our hypothesis is solid and meaningful for research. When we talk about testable hypotheses, we're referring to ideas that involve variables we can observe and measure. This is crucial because it allows us to gather data and evaluate the results in a concrete way. On the other hand, refutable hypotheses are equally important since they can be proven false, which is what makes scientific investigation both meaningful and rigorous. To put this into perspective, consider some non-testable examples. For instance, saying the more sins a man commits, the less likely he is to get into heaven involves concepts that aren't observable or measurable. Another example is if old dogs could talk, which is purely hypothetical and cannot be tested. Lastly, statements like the human mind emits unmeasurable thought waves cannot be empirically verified or disproved. Because these ideas can't be tested or refuted, they don't qualify as scientific hypotheses, nor can they effectively guide valid research. This highlights why clarity and empirical testability are essential in developing strong scientific hypotheses. To ensure quality in scientific research, we start with the foundational step of applying the scientific method along with strict hypothesis standards. This approach helps us produce research that is both credible and reliable. Next, it's critical to collect evidence systematically and objectively. Researchers must carefully gather empirical data while working to minimize any personal or methodological biases that could skew the results. Finally, fostering transparency and replicability is essential. By openly sharing our methods and findings, we enable other scientists to review, replicate, or challenge the work. This process not only promotes trust but also drives the advancement of knowledge, especially in behavioral sciences, by continuously refining our hypotheses and theories. When we take a hypothesis and turn it into a research study, there are a few critical steps involved. First, we need to operationalize the variables, which means translating abstract ideas into measurable and observable factors. Next, defining who will participate in the study is essential, since the sample can greatly influence the outcomes. And finally, we carefully plan how to collect the data to ensure it's reliable and valid. For example, imagine a study involving college students. The hypothesis might be that students using mental imagery while studying will recall more words than those who don't. Here, mental imagery is the variable we're testing, and the participants are college students. Another example involves children, 10-year-olds who view pictures recalling more items than those who see a list of words with the same content. This study explores how the form of information presentation impacts memory. Conducting research from multiple angles is also valuable. By varying who participates and how we measure outcomes, researchers can test the same hypothesis from different perspectives, strengthening the overall understanding. To sum up, the key planning steps for any study are to operationalize your variables, define your participant group clearly, and plan your data collection method thoughtfully. This structured approach helps turn ideas into meaningful, testable research. Let's start by discussing how to identify appropriate scientific questions. For example, asking how many angels can stand on the head of a pin isn't a scientific question because it's not testable. Similarly, questions about morality, like whether abortion is moral or immoral, also fall outside the realm of science. Next, suitable scientific questions are those that can be observed and tested. For instance, asking what conditions promote student learning in an elementary classroom is a great scientific question because we can gather data and analyze it. Moving on, some questions fall outside the scientific method despite being interesting. For example, wondering how life would be different if computers had never been invented is speculative and not something we can test scientifically. Now, good research hypotheses are specific and testable statements. Examples include hypotheses like increased sugar consumption leading to increased activity, smaller class sizes relating to better academic performance, or self-esteem relating to persistence at tasks. These are all clear relationships that can be investigated. Finally, poor research hypotheses are those that predict no relationship, like saying there is no relationship between fatigue and reaction time. This is not a good hypothesis because it doesn't propose a testable effect or connection. Overall, understanding these distinctions helps us design better research. When we talk about research, there are two main approaches: quantitative and qualitative. Quantitative research focuses on measuring variables to generate numerical data, which can then be analyzed statistically. It helps us understand questions like how much, how big, or how strong certain effects are. For example, we might measure adolescent depression by using standardized tests and looking at their scores. On the other hand, qualitative research takes a different approach, collects detailed observations, and produces narrative reports that describe and interpret behaviors or phenomena. Rather than numbers, this method dives into personal experiences, like interviewing adolescents to explore how they feel and then summarizing common themes that emerge from those conversations. Both approaches are valuable, but they provide different kinds of insights. The research process starts with a general idea, which serves as the foundation for everything that follows. From there, researchers carefully plan how to approach their study, deciding what variables to measure and how to collect the data they need. Once the data is gathered, the next crucial step is to analyze it, looking for patterns or answers. Finally, researchers interpret these results to draw meaningful conclusions and gain insights into their initial questions. This step-by-step approach ensures that the research is thorough and reliable. The first step in any research project is to find a solid research idea. Start by selecting a general topic that genuinely interests you or is relevant to your field. This initial broad area will be your starting point. Next, conduct a thorough literature search using databases that are most appropriate for your discipline, for example, PSYC Info if you're working in psychology. This step allows you to explore existing studies and gain a better understanding of what has already been done. As you review the literature, focus on narrowing and refining your topic. This helps you identify gaps or unanswered questions, enabling you to shape your initial broad interest into a specific, manageable research question. For instance, you might begin with broad topics like obesity, human development, or perception, then gradually hone in on a particular aspect worth investigating more deeply. After pinpointing the specific research question that explores the relationship between variables, the next step is to develop a hypothesis. This is essentially a tentative answer or prediction that guides your investigation. When formulating your hypothesis, it's important to base it on existing research or logical reasoning, ensuring it's a thoughtful and informed guess. For example, you might hypothesize that a painful stimulus will be perceived as less intense if someone is cursing compared to when they are not. This kind of statement sets a clear expectation that can be tested through your research. Now, let's talk about defining and measuring variables, which is a crucial step in any research. First, it's important to precisely define and operationalize your variables. This means translating abstract concepts into measurable elements so you can gather concrete data. For example, if you're studying the relationship between swearing and pain, you might operationally define perceived intensity as pain tolerance. In practical terms, pain tolerance could be measured by how long participants keep their hands submerged in ice water. This kind of clear, specific definition ensures that your data collection is consistent across participants and that your subsequent analysis is meaningful. Without this clarity, it becomes difficult to interpret results or draw valid conclusions. Now, let's focus on step 4, identifying participants and planning ethics. First, it's crucial to select participants who align closely with the study's goals. This means considering factors like age and other demographic characteristics to ensure the sample is relevant and meaningful. Next, determining the right sample size is essential. We want enough participants to make the findings statistically powerful and applicable to a broader population. Then, we need to develop a thorough ethical plan. This involves protecting participants' rights by obtaining informed consent, ensuring confidentiality, and minimizing any potential harm. Finally, promoting ethics throughout the research process not only safeguards individuals but also builds trust and upholds the integrity of the entire study. These ethics are the backbone of responsible research. When selecting a research strategy, the first step is to choose an approach that fits your hypothesis while balancing internal and external validity. Experimental strategies involve manipulating variables to determine cause and effect relationships, which is great for establishing causality. Descriptive strategies focus on observing and recording characteristics or behaviors without intervention, providing a detailed picture of the subject. Correlational strategies look at the relationships between variables without manipulating them, helping identify associations. Finally, non-experimental and quasi-experimental strategies involve observing naturally occurring variables, with quasi-experiments using some experimental methods but lacking full randomization. The strategy you choose will shape how you design your study and interpret the data. Now, when choosing a research design, there are several options to consider depending on your study goals. First, the between subjects design involves assigning different participants to separate groups. This is useful when you want to compare distinct conditions without overlap. Then there's the within subject design where the same participants experience multiple conditions, allowing you to observe how each individual responds to different scenarios. Next, we have the factorial design, which lets you study two or more variables at the same time, helping to understand how these factors interact. Lastly, the single case design focuses on intensive observation of one participant or a very small group, which is especially valuable in detailed in-depth analyses. Each design has its strengths, so selecting the right one depends on your research questions and resources. At step 7, we conduct the study by collecting data according to the design and ethical guidelines we've established. It's crucial to follow these plans carefully to ensure the integrity of our research. Moving to step 8, we evaluate the data using appropriate statistical methods. This analysis helps us interpret our results accurately and draw meaningful conclusions. In step 9, we report the results transparently and ethically, sharing our findings clearly while maintaining honesty and integrity. Finally, step 10 involves refining or reformulating our ideas based on the findings. This might mean improving our initial hypotheses or coming up with new research questions, effectively restarting the process. This iterative approach is essential for advancing scientific understanding step by step. When it comes to using AI in the research process, there are several key areas where it really makes a difference. First, AI can quickly scan vast academic databases to find relevant studies, which speeds up literature searches significantly. Then, in data collection, AI can automate the gathering of information from experiments or online sources, reducing manual effort and increasing efficiency. Moving to data analysis, AI algorithms excel at analyzing complex datasets and detecting patterns that might not be immediately obvious. AI can also help in hypothesis generation by suggesting new ideas based on existing data, opening up possibilities for innovative research directions. Finally, AI supports reporting by helping to summarize results and create visualizations, making it easier to communicate findings clearly and effectively. Together, these applications show how AI enhances every stage of the research process. The scientific method isn't just a straight line from start to finish, it's an ongoing, iterative process. Researchers don't simply follow steps once and move on, they constantly refine their questions and hypotheses. They often circle back to earlier stages, revising methods and approaches to improve accuracy and reliability. This cyclical nature is essential because it allows scientific knowledge to evolve over time. As new evidence and perspectives emerge, researchers revisit previous conclusions, continuously enhancing our understanding and ensuring that science remains dynamic and self-correcting. When conducting research, there are several common challenges that we need to be mindful of. First, bias can sneak in, whether it's personal or procedural, so it's crucial to recognize and minimize these influences to keep our findings reliable. Then, ethical concerns are always a priority. We must make sure to protect the welfare and rights of everyone involved in the study. Another big challenge is controlling variables. This means carefully isolating factors to establish valid and trustworthy relationships between them. Finally, maintaining objectivity is key. Even when we have expectations or hopes about the outcome, we need to evaluate the data impartially to ensure our conclusions are sound. These challenges can be tough, but being aware of them helps us conduct stronger research. Ethics play a crucial role in research by protecting both the participants involved and the overall integrity of the study. One of the key aspects is obtaining informed consent, which means researchers must clearly explain the study to participants and ensure they willingly agree to take part. Another important factor is maintaining confidentiality, which helps protect participants' privacy and keeps their data secure. Researchers also have a responsibility to avoid causing harm, which involves designing studies carefully and monitoring for any negative effects throughout the process. Finally, following established ethical guidelines and having oversight from institutional review boards ensures that research is conducted responsibly and with accountability. These principles together help build trust and uphold the quality of scientific research. Peer review plays a crucial role in maintaining high standards in scientific research. It acts as a quality control step where independent experts closely examine the study's design, methods, data analysis, and conclusions before anything gets published. This careful evaluation helps verify that the research is reliable and scientifically sound. Additionally, peer review helps uncover any errors, biases, or ethical concerns that might have been overlooked, which ultimately enhances the overall quality of the work. Because of this rigorous process, both the scientific community and the public can have greater confidence and trust in the published results. Research is evolving at an unprecedented pace, driven by technological advances and greater collaboration across different fields. One of the most transformative developments is the rise of artificial intelligence. AI tools are revolutionizing how we analyze data, recognize patterns, and even generate new hypotheses, making research processes more efficient and insightful. Furthermore, integrating knowledge from diverse disciplines brings fresh perspectives and sparks innovation, allowing us to tackle complex problems in novel ways. These advancements collectively lead to faster discoveries, improved accuracy, and deeper understanding across various areas of study. To stay at the forefront, it's crucial for researchers to continually adapt to these emerging methods, as they will undoubtedly shape the future of scientific exploration. When applying the scientific method in psychology and behavioral health, we start with systematic observation. This means carefully noticing and recording behaviors and mental processes, which helps us identify important phenomena to study. Next, researchers formulate hypotheses. These are educated guesses or proposed explanations about things like mental disorders, how treatments work, or patterns in behavior. To test these hypotheses, empirical testing is conducted, often through experiments or detailed observations, ensuring that the evaluation is objective and unbiased. The strength of this rigorous approach is that it leads to findings that are valid, ethical, and meaningful, which can then be used to improve mental health care and inform policy decisions. Some key areas where this method is applied include diagnosing mental illnesses, assessing the effectiveness of therapies, studying cognition, and researching social behaviors. When we talk about research applications in psychology, the first step is to investigate mental processes. This means looking closely at how we perceive the world, think, feel, and behave, all through carefully designed studies. Once we have a clear area of focus, researchers develop hypotheses. These are educated guesses that attempt to answer questions like how can memory be enhanced, or in what ways does stress impact our performance. To test these hypotheses, experimental methods are used to accurately measure both behavior and cognitive functions, gathering the data needed. From there, psychologists analyze the evidence to draw valid conclusions about the psychological phenomena at hand. Finally, the insights gained from this research help shape practical applications, informing clinical treatments, educational strategies, and intervention programs that are customized to meet the needs of different populations. This methodical process is what allows psychology to have a meaningful impact on real-world issues. Behavioral health research is all about understanding the factors that influence our health behaviors and outcomes. This can include issues like addiction or how lifestyle changes affect overall well-being. To gather this information, researchers use a variety of methods such as surveys to collect personal data, direct observations to see behaviors in real time, and controlled experiments to test specific hypotheses. Once the data is collected, it's analyzed statistically to uncover important trends, relationships, and sometimes even cause and effect connections. The insights gained from this analysis are crucial because they help shape effective interventions, therapies, and public health policies designed to support healthier communities. Ultimately, the goal of behavioral health research is to enhance mental health and improve quality of life across diverse populations.
Okay, so that is the end of that. I'm still working on it, but I think overall it's not a bad resource. So anyway, when you go here, oh, hold on. Okay, all right, so go back here. Okay. There we go. Okay, so here is, so we just went over that PowerPoint that I had, or video presentation. Went over chapter 1, so methods of knowing and acquiring knowledge, scientific method, and then identifying your topic, and then how to kind of incorporate research into your study. Okay, which kind of, the hypothesis, everything, which if you look kind of ties into when we go into chapters 3, okay, which is, we'll get into measurements and everything, but that right now we're just kind of looking at, okay, how do I find a research study? How do I take an idea into a thing? How do I create a hypothesis in a research study? And this shows some more details here of the hypothesis questions. And the nice thing about this whole thing with MindTap is you go through the content, the quiz counts for points, but you get these practice tests, which are really useful, okay, because a lot of this content is new. A lot of students, a lot of people don't know it until you take these courses. And then one thing just to know, week 8, the final exam is cumulative, okay? So if you think about this, you can start doing your answers. So like answers for chapter 1 and chapter 2, you could do this week or next week, because after I would take the practice test and then go ahead and answer the questions, because the content comes exactly from the textbook, okay? So that's just something to do. The only other thing besides the final is when we get to week, when you get to week 4, that's when you start the project, okay? And also, so there's a project, and then there's a thing for references and stuff, just to give you a little review on APA, okay? But otherwise, hopefully this has been useful, okay? And if you have any other questions, just send me a message in Blackboard, and have a good rest of your week. Thank you.